Okay, so now we're going to go ahead and look at how can we fill out some of the coordinate points on our unit circle. So what I did is I zoomed in on the first quadrant, so quadrant 1 of our unit circle, and we're going to focus on those points for now. So some of the points we can fill out already. So for example, we know right here is the start of our unit circle. We know it is 0 degrees and 0 radians. And remember, a unit circle has a radius of 1. So this point has an x value of 1 and a y value of 0. Now I'm going to move to up here. Right here, we know at the very top of the unit circle, we're dealing with 90 degrees. And in the last video, I showed you how you can convert from degrees into radians, but also I want you to think about if halfway around the unit circle is pi, then halfway of that distance right up there is pi cut in half, or pi over 2. So 90 degrees is pi over 2. Okay, and we know it has the coordinate point of 0, 1. Okay, so we have those values right now. So we're going to go ahead and focus on these 3 values right here, and I'm first going to focus on the first angle, which in our previous video we saw that or the previous part of, or in the beginning of the video, however I'm going to edit this, we saw that this angle is 30 degrees. So what I'm going to do to create some space, I'm just going to erase these items down here. And what I'm going to do is I'm going to take this angle of 30 degrees and I'm going to just draw a line straight down to the x-axis. Now this is a straight line, so that line I just drew and our x-axis, they form a right angle. And again, this is inside here. This angle is 30 degrees. And right now, let's just focus on the degrees for now. Okay, so we want to go ahead and find the coordinates of those points right there. Now, you guys have learned in a previous video that a point, an x and a y, you have learned that your x is your cosine and your y is your sine. So really, if we wanted to just find our x value, our x coordinate, we would simply just see, okay, what is cosine of our angle? And our angle is 30 degrees. So we would grab our calculator and we would type in cosine of 30 degrees. And the calculator would spit out some really long decimal. And I'm going to tell you that we don't really want to work with decimals there. Pretend that says decimals. We don't want to work with decimals. Decimals, especially this decimal, it's a decimal that goes on forever. So we would have to round, which means when we're rounding in math, we're no longer being super precise with our answers. So instead we want to use fractions. So let's use fractions. So that cosine of 30 degrees, it gave us some decimal. I don't want to, I don't really want to continue working with then that cosine. So let's take the sine. If we do sine of our angle, 30 degrees, and we type that into our calculator, we see the calculator would give you 0.5. And that is good news for us because we know what 0.5 is as a fraction. We know that 0.5 as a fraction is just 1/2. So that's good because, again, we can take that decimal of 0.5 and we can really easily write it as a fraction. So I'm going to go back to my unit circle and zoom in, and okay, that was sine. Remember, sine is my y coordinate, so that means this point right here, and I'm going to actually just use that as the fraction bar. The y value is 1/2, that 0.5, but remember, we're using just fractions, so the y value is 0.5. Now, I still need to find that x value, but I don't want to deal with a fraction. So what I'm going to do next is I am actually going to take advantage of the fact that we here are dealing with a right angle, or right angle inside a triangle. So this is a right triangle. Now, you are hopefully right now thinking, okay, if I'm dealing with a right triangle, there's a very popular theorem that comes with right triangles. So that is the Pythagorean theorem. Pythagorean theorem is if you have a right triangle with two little side lengths, those side lengths together form that right angle. If they have measurements of A and B, and then the hypotenuse is C, then that means A squared plus B squared equals C squared. So you guys have used that before in Math 1 and in Math 2, and we're now in Math 3 using it again. Doesn't really go away. So we are going to use that. So for this triangle, I'm going to label this in orange. Remember, this is a unit circle, so that hypotenuse, which is our C value, remember this, since it's a unit circle, it means that hypotenuse, which is the radius here, is 1. And then our y value, and our y value represents vertical distance, is 1/2. So if I know my C value and I know my B value, I can definitely find my A value using the Pythagorean theorem. So I'm going to go ahead and do that. Let me create some room down here. So that Pythagorean theorem says A squared plus B squared equals C squared. So I'm trying to find my A squared, so keep that as A squared plus, in parentheses, 1/2 squared is equal to 1 squared. Cool. And I'm going to go ahead and solve this. A squared, now 1/2 squared is 1/4. And 1 squared is just 1. I'm going to go ahead and subtract 1/4 from both sides. So then I can get that A squared by itself. When I do that, the 1/4s cancel each other out. So I have A squared is equal to, now it's 1 minus 1/4. I want you to think of this as money. If you have $1, and you're subtracting 1/4, which is just 25 cents, then you're left with 75 cents, or 3/4. So 1 minus 1/4 is 3/4. So 3/4. Always think money when you're dealing with a denominator 4. Now I want just A, not A squared, so to get rid of A squared, I'm going to go ahead and do the inverse of squaring, which is square rooting. So then I'm left with A, and what I can do when you square root a fraction, it is the same thing as square rooting the top. So I'm going to square root 3 over the square root of the denominator. So notice I'm square rooting the numerator and the denominator. Square root of 3, if you put it into your calculator, you get a decimal. Remember, we don't want decimals, so let's just leave it as square root of 3. Now square root of 4 is 2. So that means our A value is square root of 3/2. Now that is great news for us, because remember, the whole point of us doing this is that A value represented this part of that triangle, that distance right there. And that part, that horizontal distance, is represented as the x value of our point. So I'm going to zoom in. So we just saw that our x value, which remember is this length, which we just found, so that x value is square root of 3/2. So now we just have our first point in there.